Okay, now I'm recording. And then it's going to have, when you look at your reference table, which I know you all have out in front of you, right? When you look at beryllium on the reference table, there's two numbers here, 2-2. That's called the electron configuration. That's saying that the first energy level has 2 electrons in it. The second energy level has 2 electrons in it. So that's what I drew here. 2 electrons in the first energy level and 2 electrons in the second energy level. Now, this last energy level, the outermost energy level, is called the valence shell. Everybody know that? And so it has 2 valence electrons. There are the electrons that are on the last shell. Okay, just making sure you're with me. Okay, I want to, let's draw a Lewis dot diagram, and I'll show you how to do that just because it will show up, and I did not include it on the test, but it's really fairly easy. It's easier than drawing this, because with a Lewis dot diagram, we assume that the inside, which is the kernel of the atom, is going to remain the same. So we draw the symbol, which in this case is beryllium, and we want to diagram just these 2 dots. So we do it exactly the same way we would do if we were drawing it on the circle, except for we just draw the dots. One goes at 12 o'clock, one goes at 3 o'clock. And you don't have to draw all the inside circles. You only draw the valence. So if I was to draw carbon, how many dots would I draw around carbon? How many valence electrons does it have? 4. So I would do 1, 2, 3, 4. If I were to draw fluorine, how many dots would it get? 7. 1, 2, 3, 4 at 12, 3, 6, and 9 o'clock. And then 12 o'clock, 3 o'clock, 6 o'clock until I got to 7. It's a lot easier than drawing these guys, and a lot neater, because you don't have to draw all those crazy circles. You're just diagramming the outside electrons. All right. How is an atom different from an ion? In an atom, the protons are equal to the electrons. In an ion, the protons are not equal to the electrons. What's changing? Are the protons changing or the electrons changing? The electrons are changing. Okay? When you lose an electron, let's highlight this. I'll use orange because it's almost Halloween. Okay? When you lose an electron, you become positively charged. That's called a positive, right? It's called a cation. And when you gain an electron, you become negative, and that is an anion. Okay, so cations and anions. Those are on your test on Friday as well. Why do atoms want to gain or lose electrons to get 8 in the valence shell? Well, they want to because they want to become stable. They want to be happy with themselves. They want 8 electrons in that valence shell, or 2 if they are in the first period, which is hydrogen, helium, just those atoms that have 1. Are we good, girls? Because I'm getting distracted. So if they have 1 shell, they only need 2 electrons to be stable. Hydrogen, helium, lithium, and beryllium do that. So if you look at, let's just say, hydrogen. Let's do hydrogen here. Hydrogen. It will have 1 valence electron. Let's draw it on top like I showed you to. Okay? How many does hydrogen want to have? 2, because it only has 1 energy level. And in that first energy level, where n equals 1, the maximum number of electrons was 2. Do you remember that from 2n squared? So this hydrogen only wants 2 electrons. Helium is stable already. It already has 2 electrons. You can draw it like this, or you can draw it with the 2 electrons together, which was generally the way we draw them. The first 2 electrons can be drawn together. That goes into a whole deep AP style lecture on why these electrons can go together. And the reason, in a nutshell, making it very easy for you to understand, is those electrons have less energy than the other 6 that I would put on there. So those 2 are going to get paired up first. Don't worry about that unless you want an in-depth going into the chemistry of it. Just know that if you put these 2 electrons like this or like this, both of them are acceptable at the Regents level. Okay? If you look at lithium, lithium has 1 valence electron. It's in the first column. But that 1 electron is in the second energy level. So if it loses that, it will have a full shell. It will become lithium plus 1, which will essentially look like this in the Bohr diagram, with 2 electrons or 2 electrons, like that. Okay, it only has 1 ring around it. So it is perfectly content losing that 1 electron. You see where I'm going with this? The other elements on the periodic table, they all want to have 8. They can never have more than 8. Please, please, I am begging you, and I've seen this every year of my career. Don't give me something that looks like this. I don't know what that is. Okay, I don't know if I drew 20 dots there. A lot of people are like, "Oh, calcium has 20 electrons. Let me just draw a bunch of random dots around calcium." No. When you're drawing a Lewis dot diagram, first off, you are only diagramming the electrons in the valence shell. So that very last number, and for calcium it's going to be 2. 1, 2. Done. Don't give me anything more. Also, don't ever have more than 8 electrons around that. Somebody asked me in my red class this morning, can it have more than 8? In a nutshell, yes it can, but not at your level. At your level, Regents will never give you more than 8. So never, ever, ever put more than 8 in that valence shell, and then you'll always get it right. So let's say we have neon. How many dots am I putting around neon? 8. 1, 2, 3, 4, 5, 6, 7, 8. Done. Don't give me like rings and rings of electrons around there. Only a maximum of 8. Okay. Where am I? Fancy meeting you here. Why do atoms gain or lose electrons to have 8? Because they want to become stable. The electrons, or the atoms that are in this last column over here, they're all circled over here. Neon, argon, krypton, xenon, and radon. They all have 8 in their valence shell. These elements don't react with anything. They are stable. They will like go around the world and they're like, leave me alone. I don't want to take electrons away from anybody. I don't want anyone taking electrons away from me. I am perfectly happy by myself. They are actually called the noble gases. They're like the royals. They're like the kings, the queens, the jesters. What else is it? Royal. Princes and princesses. Okay? Nobody bothers them. They're happy. They go about their life. They have their 8. They're good. Okay? All right. The next one says, what is an anion? An anion is a negative ion, and it's formed when you gain electrons. So the number of electrons is going to be bigger. That's why that little thing is going that way, than the number of protons. You're going to have more electrons than protons. You don't change your proton number. You change your electron number to make an ion. And you're going to have more electrons than you have protons. If they give you something and they say you have an atom, I know I'm using the word atom, but in the atom you have 9 protons and you have 10 electrons. Is that a positive or a negative ion? Negative, because you have more negatives. You have 10 negatives and only 9 positives. So this would be F with a -1 charge. How did I know it was F? 9 protons. 9 protons, so it's fluorine. Okay, and then the cation is the opposite. It's going to be a positive ion. It's going to lose those electrons, so you're going to have more protons than electrons. And that's why I have the little caret thing going in this direction. Do you guys call this a caret? What do you call this thing?
An alligator.
An alligator? A greater than, less than sign? Okay, so you're going to have more protons than you do electrons. I call it a little caret. It looks like a caret to me. All right. Lithium. Chemical symbol is Li, capital L, lowercase I. It has 1 valence electron. It's in the first column on the periodic table, group 1. All the elements in group 1 have 1 valence electron. I'm wandering around with 1 electron. I need to either get 7 more or lose that 1. What's easier for me to do? Lose the 1. So the elements that are on the left side of the periodic table, if I can bring up a periodic table here, let's see if we have one.
You got it.
I know, I've got it somewhere. Here's a periodic table.
Yep.
It's coming.
Almost. There you go.
And then I've learned how to rotate it. Look at me go. Okay?
That was
So,
last year. Sorry.
don't you have someplace to go? Lithium is a loser. It only has 1 electron in its outside ring, its valence shell, so it doesn't want to keep that 1. And it's never going to be able to go out into the universe and find somebody to give them 7. Think of those electrons as like dollars. I got $1 in my pocket. I need to buy something that costs 8. I go to my friends, can I have $1? Can I have $1? It's a lot of work to go get 8. It's a lot of energy to go do that. But if one of my friends has 7 and I give him my $1, it's not as much work. I just hand over my $1. So these guys lose electrons very easily. They're losers. And if you go to this side of the periodic table, like fluorine, chlorine, bromine, all these suckers over here, they have 7. They're going to be the ones who are like, give me your electron. And they take it. Okay, they're the strong ones. These guys never fight. They already have full valence shells. They don't need to go and find any electrons. So those are called the noble gases over there. All right, back to business. When it loses an electron, it becomes positively charged. So we're going to put the little +1 symbol up there. I added as a little bonus the Lewis dot diagram for lithium. See how it only has 1 dot? Because it has 1 valence electron. Good? Okay. Nitrogen. Nitrogen does a bunch of funky things. It gains electrons, it loses electrons, but I said just take the top one for now. It has 5 valence electrons. It's going to gain electrons. And when it gains electrons, it's going to become a -3 charge most of the time. Boron is in group 13. Do you know what I'm saying by group 13? It has 3 valence electrons. It's going to lose, and it's going to become boron with a +3 charge. This is a cation.
Positive.
It's positive, yes. Fluorine, it's going to become a negative. It's in group 17, which has 7 valence electrons, except for helium. I lied. Scratch that from the record. Helium is in group 18. Okay? It has 7 valence electrons. Sulfur is in group 16, has 6 valence electrons. It's going to gain them and become -2. See how it has 6 dots around it? And do you see how I went around once and then I ran around the second time so that my dots are in the correct spots? I will say this, one other thing. Sometimes, and this does show up every once in a while, I always start my dots at the 12 o'clock and then go 3, 6, 9, 12, 3. Sometimes some books try to get fancy and they might start here. 3, 6, 9, 12, 3, 6. It's the same thing. It's just rotated one. Do you see that? Look, I see some furrowed brows. Okay. This is how I just showed you to do it, right? You take the electrons, you put 1 here, 2, 3, 4, 5, 6. Okay? Well, sometimes the books try to get fancy and they're like, we don't want to start at the top. We're going to start here. 3, 6, 9, 12, 3, 6. You see how it's just rotated over? It's the same thing. It's just rotated. I could even start at the 6 o'clock and go like that. It doesn't matter. But since we're all in the same class and we're doing the same thing, let's keep it consistent and just do it that way. Start at the 12. 12, 3, 6, 9, 12, 3, 6, 9. Okay? All right. Oxygen, phosphorus 5, gain P minus 3. Oxygen is in group 16, so it has 6 valence electrons. It gains 2 electrons, so it becomes a -2. Too fast, or are you okay? You're just checking your work. All right, calcium should be losing electrons and becoming calcium plus 2. Magnesium should be losing them, becoming magnesium plus 2. Sodium should be losing 1, becoming sodium plus 1. And potassium should be losing and becoming potassium plus 1. Bye, Jack. Okay. Any questions on that? Everybody good? All right, let me stop this for a second.